We're going to talk about fraction division using the partitioning, or how many in one group perspective of division, and we'll explore how to solve these problems with visual representations. Let's step back and remind ourselves some things about multiplication. So with multiplication, I can think of the first factor as the number of groups, the second factor as the size of the groups, or the units in one group, and when I multiply them together, I get the total units. Any of these numbers can be fractions, then, for example, groups just becomes fraction of a group. So in the division problems that we're going to do, we can write multiplication problems as division. Since we're answering how many in one group, that's going to be the part that I don't know. I don't know the units in one group, so that's what I'm trying to solve. So when I rearrange, I'll have total units divided by number of groups, and my answer will be the units in one group. We'll look at two examples. The first one reads, if 3/4 of a liter fills 1/3 of a jug, how many liters of water will one jug hold? How many will one hold? How many units in one group? The second problem starts off the same. If 3/4 of a liter of water fills 1/3 of a jug, how many jugs will 1 liter fill? So now we're looking at 1 jug, 1 liter. That's how these problems are going to differ. So let's go to the first one. I've color-coded it, and let's talk about how I knew. So the question, how many liters of water will 1 jug hold? We're looking at the structure here for the how many in one group problems. I'm going to key in on the number 1 jug, 1 group, jug. So my groups are going to be the jugs. How many units? How many liters? So my liters are going to be the units. So once I know that the groups are the jugs, here are my jugs, so 1/3 is the groups, 1/3 jug. Here I know that my liters are the units, so here are the liters, they're going to be my total units, 3/4 of a liter. 3/4 divided by 1/3 is going to give me the number of liters in one jug. So let's solve this first with a table. These problems work really nicely with a table. We'll have liters, we'll have jugs. We'll fill in the given from our problem. We have 3/4 of a liter fills 1/3 of a jug. These guys are paired, and we're trying to figure out 1 jug, how many liters? Well, I just used multiplicative reasoning to get from 1/3 to 1. I can see that I need to multiply by 3. So I'm going to end up with 9/4. So my answer is 1 jug will hold 9/4 of a liter. So 9/4 of a liter per jug. If I look at these units, liters per jug, we can write that as division, liters divided by jugs. So I could have used this understanding of units to set up my division problem. What were my liters? My liters were 3/4. What were my jugs? 1/3 of a jug, and that would give me the division problem that I'm trying to solve. Let's use a double number line. Our double number lines are going to look a little different than they did with our measurement division. So in this case, I'm going to label my liters and my jugs. And I'm going to start with 1. I'm asking about how many in 1. So I'm just going to mark 1 right here, 1 jug. And this should correspond to the same location, the number of liters in 1 jug. Then I'm going to come back, and I know that I was talking about 1/3 of a jug. So I'm going to partition the distance between 0 and 1 into 3 equal parts, and I'll have 1/3 of a jug right here. I'll copy the same markers up on top with the same spacing, and I know that 1/3 of a jug corresponds to 3/4 of a liter. And so in this problem, I can think about, well, I have 1, 2, these should be equal spacing. My freehand was a little bit off here. I have 3 sets of 3/4 which is 9/4, and I'm in liters. So all I had to do was figure out the value of one space right here, and then I can see that I needed 3 spaces until I got to the desired location for my answer. Finally, let's do a math drawing. So I'm going to draw a rectangle, and I'm going to say that this represents 1 jug, and it also represents some number of liters. This is the problem I'm trying to solve, how many liters in 1 jug. So I'll copy down, I'll try the best I can to have the same dimensions on my rectangle here. And now my jug, I'm going to break into 3 equal parts, and I'll have 1/3 of a jug down here, and this up here represents 3/4 of a liter. Since I know the value of 1, what am I trying to find? I'm trying to find 3 sets of 3/4 of a liter. And that's going to give me 9/4 liters. So up here I can fill in 9/4. Let's go to our second problem. So in our second problem, we had how many jugs will 1 liter fill? Again, I key in on 1. 1 group, 1 liter. So my groups are going to be liters. How many units? How many jugs? So my units are going to be jugs. So this time, my jugs, let's see, 1/3 divided by my groups. My groups in this case are liters, divided by 3/4 is going to give me my number of units in 1 group. So this is the division problem, 1/3 divided by 3/4. In the previous problem, it was 3/4 divided by 1/3. So let's do a table again. We have liters, we have jugs, 3/4 of a liter from the problem, 1/3 of a jug from the problem, and this time I'm trying to figure out 1 liter. Now notice I left a space here. I wasn't given the unit fraction for liters, so I might have an intermediate step. Often in tables we go through a unit fraction or just the value 1. So to get to the unit fraction 1/4, I'd have to multiply by 1/3, and then to get from 1/4 to 1, I'd have to multiply by 4. So to keep the relationship the same, times 1/3 will give me 1/9, times 4 will give me 4/9. So my answer is 1 liter of water fills 4/9 of a jug. I can rewrite this as 4/9 of a jug per 1 liter. Why am I doing this? Because if I can get 1 in the denominator, jugs per liter, that's going to be jugs divided by liters. This division problem, jugs was 1/3, liters was 3/4, is 1/3 divided by 3/4. Let's do our double number line. Now with a double number line, I like to put the, to kind of match our 1 in the denominator, I like to put the unit that has 1 on the lower line here. So this time we had liters on bottom, jugs on top. So I'm going to mark 1 liter. That corresponds to some unknown number of jugs. What do I know about liters? I know that I had 3/4 of a liter, so I'm going to partition my 1 liter into 4 equal parts, and I'm going to mark 3/4 of a liter. I'll copy the same tick marks above, and 3/4 of a liter corresponded to 1/3 of a jug. It doesn't matter that my spaces don't look like 1/3. I can have any number line numbering on top that makes sense with the problem. So again, I want to count up my number of spaces, and then I'll have 4 sets of something. I need to know what one space is worth. So again, I'm going to think about this distance between 0 and 1/3, and I need to break it into 3 equal parts. So I need to have 1/3 of 3, or 1/9 right here. So each space is worth 1/9. 4 sets of 1/9 is going to give me 4/9. My units are jugs. Again, to get here, I partitioned into 3 parts, so I needed 1/3 of 1/3 to give me 1/9. We're going to do a math drawing. I am going to draw a rectangle. The rectangle is going to represent 1 liter, and we're trying to figure out how many jugs are needed for 1 liter. So I'll come along here and try to draw my same box. And now 1 liter I'm going to partition into 4 equal parts, and I'm interested in 3/4 of a liter. 3/4 of a liter I know fills 1/3 of a jug. So this one's harder than the previous one because I want to know the value of one of these regions. So I'm going to have 4 sets of something. Well, I know from a liter perspective, this represents 1/4 of a liter. So I need to know from a jug perspective what I have here. Well, my jug 1/3 spans these 3 regions. So I need 1/3 of the 1/3, or this region represents 1/9 of a jug. So I'll have 4 sets of 1/9 of a jug will give me 4/9 of a jug for 1 liter of water.